the uses of the fundamental theorem of arithmetic? There are actually various uses of it. So let's just check the very basic one. So the very first one is that this theorem can be used to find out the highest common factor or greatest common divisor and lowest common multiple. Let's first check out what is the highest common factor. So the HCF and the GCD are one and the same thing, but they are, in some countries they are expressed differently. In some countries they call it as HCF, and in some other countries they call it as GCD, but they are the one and the same thing. The HCF and the GCD are very much used in number theory, in quadratic, in solving those quadratic equations and other stuff. Let's take for example two numbers, that is 4 and 16. Let's try to find out what is the GCD of these two numbers. GCD of 4 and 16. Alright, now greatest common divisor. Okay, divisors. What are the divisors of 4? Okay, so 4 is a number that can be divided clearly by 1. 4 can be divided by 1. 4 can be divided by clearly by 2, and 4 can be divided by 4 itself. Can it be divided by any other number? No. Now take the example of number as 16. 16 on the other hand can be divided by 1, 2, 4, 8 and 16. So all of these numbers are the divisors of 16. If you divide 16 with 16, you get the result as 1. If you divide 16 by 8, you get the result as 2, and 16 divided by 4 gives you the result as 4. So among these, between these two numbers 4 and 16, which one number do you think is the greatest common divisors? So the common divisors between 4 and 16 are 1, 2 and 4. Yes, so 1, 2 and 4. So these three numbers are the common divisors of 4 and 16, but you see that 4 is the greatest one, so we can call that 4 is the GCD of 4 and 16 taken together. So this is the GCD of these two numbers. Let's look at another example. Very simple one. Let's take another example, that is 10 and 25. We repeat the same process. What are the numbers that can cleanly divide 10? So the first number is 1, the second one is 2, the third one is 5, and the fourth one is 10. So these are the numbers that can cleanly divide the number 10. And 25 can be cleanly divided by 1, and the other number is 5. There is no other number that can divide 25. Or there is the number 25 itself. So 25 can be divided by 1, 5 and 25. No other number. Alright. Now what are the common factors between 10 and 25? Common divisors. So the common divisors or common factors between 10 and 25 is 1 and 5. So this is 1 and this is 5. So these two numbers are the common divisors of 10 and 25, and among these the greatest one is 5. So therefore you can say that the GCD of 10 and 25 is the GCD of 10 and 25 is 5. Now how do we emulate the same example using the fundamental theorem of arithmetic? Now the number 4 can be broken down as 2 times 2. Okay, so we can write it as 2 squared. Similarly, and the number 16 can be written as 2 times 8, that can be written as 2 times 2 times 4, and that can be further broken down into 2 times 2 times 2 times 2, and this is 2 powered 4. So we can write 4 as 4 is equals 2 squared, while 16 can be written as 2 powered 4. So now the thing is, we have broken down 4 and 16 as factors of prime. 2 is a prime number, and there is no other prime number that they are factors of. They are factors of only the prime number 2. So now to find out the GCD or HCF, GCD of 4 and 16, we look at all the common prime numbers that they are factors of. All the common prime numbers. The only common prime number is 2, so we write it as 2, and we check what is the minimum power does it have. See, minimum. So the minimum one is 2, so here we write as 2 power 2, and the answer is 4. So the GCD of 4 and 16 is 4. Now let's try to solve our second example using the fundamental theorem of arithmetic. The second example was about to finding the GCD of two numbers, that is 10 and 25. 10, we try and break it down as the factors of the prime. So 10 can be broken down as 2 times 5. It cannot be broken down more because 2 and 5 both are prime numbers, and therefore we have reached the limit. 25 can be broken as 5 times 5. Okay, it cannot be broken down more. So we can further write this as 2 power 1 times 5 power 1. Okay, and for in the case of 25, can we write it as 2 power 0 times 5 squared, because anything to the power 0 is 1. Okay, so 2 to the power 0 is equal to 1. So therefore, just to simplify, just so that it looks better in an organized manner, so we just write 2 to the power 0, while it does not hold any kind of meaning. To find out the GCD of these two numbers, GCD of 10 and 25, what do? We write down all the factors that are involved in the factorization of 10 and 25, all the factors, so all the numbers. So we write 2 and 5 because 2 and 5 are both present in the factors of 10 and in the factors of 25. So 2 times 5 and 2 power 0 times 5 squared, both of them are present. So the GCD of this is that. Now 2 to the power, so we write here as minimum and minimum. So what is the minimum power of 2 in both of these cases? In the case of 2, in the case of 25 and in the case of 10, what is the minimum power if you compare all of them? The minimum power of 2 is 0 and the minimum power of 5 is 1. Right, so therefore we can say that the GCD of 10 and 25 is therefore 1 times 5 equals 5. So we can say the GCD of 10 and 25 is 5. And this is how we can use the fundamental theorem of arithmetic to find out the GCD of any number. Thank you.